All right, everyone. So today we're going to cover the SAT Test 3, Section 4, and we're going to cover some selected problems from that exam. So without further ado, let's get into it. So problem 16 says, graphs of the functions f and g are shown in the xy plane above. And they want to know for which of the following values of x, essentially, does f of x plus g of x equal 0. So they want to know, okay, so if we add together these two values, when will they cancel out, essentially? And so what that means is that, well, f of, for example, f of 3 plus g of 3 might equal 0, right? Or might not equal 0, right? Just means that these two quantities have to be equal. So if we look at the graph, right, and we look at this point here, we look at this point here, well, we can see that, you know, this is what stands out to me, right, in f and g, that these each have a height of 2. This has a height of 2, and this has a height here of -2. And if we observe here, well, these both occur at f of -2, which basically means that, well, f of -2, this is f of x, equals -2, and f of 2 equals, or g of 2, sorry, equals 2. This is just converting what I see on the graph into text. And g of 2 equals 2. So this is just the fact that these, this is just what these equal, right? So if we were to add together, sorry, it's g of -2 and f of -2. If we add these together, right, plus g of -2, well, we get 0, right? So the key here is, well, observing the graph and noticing that, well, both these heights are opposites, 2 and -2, right? And since they cancel, well, all we have to do is find, okay, what x value produces both of the heights, and respectively, right? And that turns out to be -2. So the correct answer for 16 is B. All right, let's take a look at 17 and 18. So 17 and 18, they rely on this data here. They give us two functions, both in terms of P, S and D, supply and demand. It says the quantity of a product supplied and the quantity of product demanded are given by the functions. Great, okay. So they want to know, essentially, how will the quantity of the product supplied to the market change if the price of the product is increased by 10? Okay, so we're looking at the supply function. So S of P equals 1/2 P plus 40. We're looking at how the supply changes. Product supplied to the market change if the price of the product is increased by 10. Well, here's one way to look at this problem. So we can say, okay, well, let's take S of 0. Right, S of 0 is equal to 40, right? Because when P is 0, this cancels out and we get 40. So if we increase this by 10, which is 0 plus 10, so taking S of 10, well, what will the price change be? So S of 10 is equal to 1/2 times 10 plus 40, which is equal to 45. So if we compare 0 and 10, well, you know, we can see that, well, based on, since this is a linear function, right, we can see that clearly, well, the price goes from 40 to 45, and since it's linear, this increase would be constant, right? Well, the quantity supplied, right, will increase by 5 units each time we up that, right? So a lot of problems like this. But again, the key here is just comparing a value at 0 or a value at 5, and then comparing it to the next highest value. In this case, we're adding 10, right? Okay. Question 18 asks, at what price will the quantity of the product supplied to the market equal the quantity of the product demanded by the market? Well, to solve this, right, all we have to do is set the supply and demand functions equal to one another, right? Because we want to find that P that satisfies both of them, makes both of them equal. Well, the way to do that is just to say 1/2 P plus 40 is equal to 220 minus P. The price will supply equal to demand. Well, when these two are equal, right, P will be something, right? So let's simplify this. So 1/2 P plus P on this side cancels out. We'll get 3/2 P is equal to 260. And therefore, if we simplify this, well, P is equal to 120. So 120 times 3 divided by 2 is 180. Sorry, this is not 260, this is 180. It's my mistake. 180. Therefore, P is in fact 120. And if we notice what a value of 120 will make both of these functions equal to one another, that's what the problem's asking for. All right. Question 21. Question 21 says, it's asking about each of these each answer choice here is a plan, so to speak. So it says the following 4 types of saving account plans, which option would yield exponential growth of the money in the account? So just to reiterate, exponential growth is not linear. It doesn't increase continuously. So it's not like up 1 over 5, up 1 over 5. Instead, right, it's increasing, exponentially. So a function like 2 to the x, right? Every time x is increasing, right, the function essentially outputs something with a higher power. So we have 2 to the 1 as an output, 2 squared, and so on. These functions generally increase a lot faster than linear or even quadratic functions, right? So that's what we're looking for here. We're looking for something that produces this type of growth pattern. So each successive year, 2% of the initial savings is adding up to the value of the account. Well, that's not exponential because remember, we're talking about 2% of the initial savings, and that's always going to be the same number, right? Because suppose the initial savings was 1, well, 2% of that, right, is 0.02. And if we add that on every year, right, then it's going to be linear because each year we're just increasing by 0.02. There's nothing exponential happening there, just a linear increase. So A is not correct. Same thing is true of D, right? Each year, $100 being added, right? Again, it's the same quantity being added every year. The quantity that's being added isn't increasing exponentially. It's in fact staying the same. So D, also incorrect. Let's take a look at B. Each successive year, 1% of 1.5% of the initial savings and $100 is added to the value of the account. Again, that's just combining A and B. Again, it's not what's being added is not increasing. It's still constant, therefore it's linear. And so, well, by process of elimination, that leaves us with C, but also C relates to the current value. It says 1% of the current value is added to the value of the account, which means that, as the value grows, so 100 and 101, well, the percent is being taken from this. So basically, as this gets larger, the percent that's being added also gets larger, right? 1% of 101 is larger than 1% of 100, and therefore, this is in fact dictating exponential growth, or growth that where essentially the chunk that's being added is not constant, as in a linear function, it's increasing. So that's what we're looking for, and that's why it's C. All right, 22 says the sum of 3 numbers is 855. And they tell us one of the number x is 50% more than the sum of the other 2 numbers. We want to find x. Okay. So I'm going to convert this into a system of equations. I'm going to call my 3 numbers x, y, and z. I'm going to say x plus y plus z equals 855. And then I know that one of the numbers x is 50% more than the sum of the other 2 numbers. Okay. So what does that mean? We've y plus z. And x is 50% more, so it's 1.5 times this, right? Because it's not 1% this, it's 50% more than the sum of these other numbers, right? Great. So now we want to find the value of x. Well, how do we do this? Sum of 2 numbers is this. This is this. Well, we know that x, therefore divided by 1.5 equals y plus z. So x over 1.5 equals y plus z. And I'm using the 1.5 because 1.5 as a decimal, right, represents 150%. So since it's 50% more than the sum of the other 2 numbers, the whole quantity is 150%, right? So this is y plus z is x over 1.5. Great. Then we can take this value here and we can substitute it back in for y plus z in this equation, right? So we'll have x plus x over 1.5 equals 855. Well, what's 1.5? That's 3 halves. So we have 2/3 x, right? Because this is 3 halves. Whether x divided by 3 halves, then reciprocating that, we get 2/3 x plus 3/3 x equals 855. So it's 5/3 x equals 855, which means that essentially what we're looking for is 3/5 times 855. So we'll do that out by hand here. 855 divided by 3. Divided by 5 rather. 1 minus 5, that's 3. It's a 7. Sorry, rather, that's a. That's 3. 5. It goes in 7 times. Minus 35, we get 0. Our answer is 171. Right, and then we take 171 and we multiply it by 3. And what does that give us? 171 times 3 is actually equal to 513. So therefore, that's our answer, right? Again, all we're doing in this problem, we say x plus y was equal to this, and then we say, well, okay, x is equal to 50% more than this, right? So therefore, x is equal to 150% of this. We divide both sides by this to get y plus z isolated. Once we find y plus z in terms of x, then we just get the single step equation, and we can find our answer here. So once again, the answer is B. All right, everyone, so let's take a look at question 24 here, which says, Mr. Cole has a beaker containing n milliliters of some solution. He's going to distribute it to students at his chemistry class. So we have some conditions here. If he gives each student 3 milliliters, then he will have 5 milliliters left over. But in order to give each student 4 milliliters of solution, he will need an additional 21 milliliters. So what we're going to do here, and how many students from the class is the question, is look at each of these answer choices here and determine which one satisfies both conditions, starting with A. So if he had 16 students, right, well, then, if he gives each student 3 milliliters, he's essentially giving out 48 milliliters, right, total. But it's saying he'll have 5 milliliters left over. If he gives each, so he'll have 5 left over, he gives each student 3 milliliters. So he'll have in total, therefore, 48 plus 5 milliliters, which is going to give me 53. So he started out with 53 milliliters. That's what satisfies the first part. Now let's see if it satisfies the second part. Now, in order to give each student 4 milliliters of solution, so that's going to be 16 times 4, he will need an additional 21 milliliters. So that's 64, and clearly that's over 53. But what's the difference, right? The difference in this case, well, is 11. So he will need an additional 11 milliliters to give each student 4 milliliters of solution. So he'll need 11 more. So clearly that's not satisfying the 21 milliliter condition here. So we can rule out A. Now let's take a look at B. Well, B, we'll do, B is the same sort of principle. We have 21 students, okay. So 21 times 3 is 63. And he'll have 5 milliliters left over, so that's 68. So plus 5, 68 to start with, right? And then if he gives each student 4, that's 21 times 4. That's 84. What's 68 minus 84? Is that going to be equal to 21? We're saying we'll need 21 more to give each student 84. Well, 68 plus 2. No, it's going to be 16 milli more. So that does not satisfy both conditions. So B can be ruled out. Now let's take a look at C. So we have 23 times 3, right? If he gives each student 3 milliliters, what is that going to be? Well, 23 times 3 is 69, which adding 5 is 74. So 74 milliliters. And now 23 times 4, it's 80. That's going to give me 92. Well, if he gives each student 4 milliliters, he needs 92 milliliters. So this is saying he'll need an additional 21. Well, what's 92 minus 74? That's 12. So that'll be 8 mil more. So again, it's not 21 mil more. He won't need 21 mil. In fact, he'll only need 8. So 23 was ruled out. Now let's take a look at the last one. Well, since all these are ruled out, D is the correct answer. We can say that with decent certainty, but let's confirm that. So 26 times 3, that's going to give us 78. Add 5. That gives us 78 plus 5, 83. And 26 times 4, well, that's 24 plus 80. That's 104. If we look at the difference here, what's 104 minus 83? Well, that's 21. So indeed, he'll need 21 milliliters more to satisfy that condition. So in this case, our correct answer is indeed 26. All right, so let's take a look at question 25. So here they want us to find the volume of this grain silo, which is built from 2 right circular cones and a right circular cylinder, and they're giving us some measurements here. So they want of the following, which of the following is closest to the volume of the grain silo in cubic feet? Okay, so there's 2 formulas we need to know here. That's that the volume of a cone is 1/3 times pi times the radius squared times the height of the cone, and the volume of a cylinder is simply simply pi r squared, times the height, right? So these are the 2 formulas given all the parameters: height of a cylinder, radius of a cylinder, et cetera, right? So solve this problem, right? Well, we have 2 cones, one on the bottom, one on the top, and we essentially have to add up all of these sort of shapes to find the total volume. So we can start up by the cylinder. If we look at the cylinder in the center here, well, we can see that it has a height of 10, as given in the problem, and we can see that, well, the base here, which is what r is referring to, has a radius of 5. So the volume of the cylinder, therefore, is pi times 5 squared, which is 25, times 10. So that's going to give us 250 pi for the volume of the cylinder here. And now we have, well, we have two cones here, right? We can see that both these cones have an equal, we're going to have an equal volume because, well, this cylinder has an equal top and bottom, and the cones have the same base, so to speak, and the base has the same radius. So essentially what the volume of these cones is going to be is just twice the volume of one of the cones. Well, as we can see in the problem, we know the radius of the cone is 5 feet, height of the cone is 5 feet. Well, so to find the volume of both cones, we'll just do 2 times 1/3 times pi times the radius square, which is 25, times the height, which is 5, which is 2/3 pi 25 times 5 times 125. So 250 thirds pi plus 250 pi. And whatever that evaluates to, which is approximately 1047.2. So, I mean, based on that calculation here, the answer is D, right? All we did was find the volume of the cylinder. The cones have equal volumes. You do twice them, and you get your answer. All right. Question 26. In the xy plane, the line determined by these 2 points, 2 comma k and k comma 32, passes through the origin. Now they want to find, okay, what is the value of k? Well, we know that these this line passes through the origin, so we know that it's something in terms of y equals mx. There's no y-intercept, right? Because of the fact, well, the y-intercept is 0, 0. There's no x-intercept either. X-intercept 0, y-intercept 0. So I'm just going to perform a manipulation here. I'm going to attempt to find the slope in terms of k. So that would be y2 is my 32, y1 is my k, x2 is my k, and what's it called? X1 is my 2. So 32 minus k over k minus 2 is equal to the slope. It's the same thing as, well, since this is passing through the origin, right, we can set this equal to, we can do the same thing with k comma 32 and 0 comma 0. Since we know that this passes through the origin, we can, again, make another expression in terms of k, and then we'll get a proportion we can solve for k. So we'll get 0 minus 32, that's negative 32, over 0 minus k, which is negative k, which is the same thing as 32 over k. 32 over k is equal to this thing. So now we can cross multiply and solve. So we'll get 32k minus k squared equals 32k minus 64. These two cancel. K squared equals 64. And therefore k is equal to plus or minus 8. They're asking us which could be the value of k. Well, it's none of these because they don't contain an 8. And of course, we can take the positive value here, and our answer would be 8. So again, all we're doing here is we're using the slope equation to write, to essentially write the slope in terms of these 2 points. And then, well, we're using the k comma 32 point and 0, 0 to make another relationship that's the same, right? Because obviously these are both on the same line, they're gonna have the same slope. We're setting them equal to each other, then we're solving. You could do the same thing with this point, 2 comma k and 0, 0. I just chose k comma 32, but again, since they're both on the same line, you could choose either one and get the same result. All right, 27. So a rectangle is altered by increasing its length by 10% and decreasing its width by p%. And these altercations decrease the area of the rectangle by 12%. Then what is the value of p? So we can say we have some original rectangle. I'm just going to use a square because the square is a rectangle and it'll work for this problem. So we have a rectangle with every side equal to 1. So we're increasing its length by 10%. So the new rectangle is going to have a side of 1.1, a length of 1.1. Because 1.1 is 10% of 1. We're adding that onto the 1. And it's decreasing its width by p%, right? So it's 1 minus essentially p over 100 times 1. Right, because if we convert a percent to a decimal, well, we're dividing the percent by 100. And we know that these alterations are decreasing the area of the rectangle by 12%. So the area of this original rectangle is 1. If we decrease that by 12%, right, it becomes 0.88, right, because 1 minus 0.12 is 0.88. So, well, we know that the new rectangle has an area of this, and this is the length, and this is the width. So we can multiply these together to find the value of p. So we'll get 1.1 times 1 minus p over 100 equals 0.88. So we get 0.88 divided by 1.1 essentially, if we simplify this, we get 1 minus 0.88, right, over 1.1. So it's going to be that step here equals P over 100. So if we multiply this whole thing by 100, we'll get our value of P. So what's 0.88 divided by 1.1? Well, the same thing as 1 minus 88 over 110. So it's 110 minus 88 over 110. All right, we can do the math out there, 110. That's 2. Giving us a value of 22 over 110. Sorry, 110. And that's going to be equal to P. So working up here again, start up here. P is equal to 22 over 110. Well, what is 22 over 110 simplified to? 22 over 110. Well, that simplifies to 20 over 100, right? If we divide out and we convert that, so if we divide 22 by 110, we can see clearly that, well, 22 is 1/5 of 110, right? Therefore, it's equal to 20 over 100, right? And because of that, our answer is, in fact, 20 as a percent. So all we did here was we took, it says it's a rectangle, and therefore a square is a rectangle. So we took our rectangle with side 1. Then we changed some things about its sides, right? And then we, since length times width equals the area, we multiplied 1.1 by this expression, giving us that alteration by P%, right? And then we're solving an equation to find the answer. Great. Okay, let's take a look here. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. Okay, so we know the present population is 50,000, so all these have the present given here. It's decreasing by 10% every 20 years. Well, okay, so what would that mean? That would mean in 20 years, when T is equal to 20, then we're going to see 90% of the initial population. Okay, so that tells me something. So I tend to, based on that, select an answer that displays that. So if I look at D here, right, when T is equal to 20, it will get 50,000, right? Sorry, the comma's there, yes. 50,000 times 0.9 to the power of 20 over 20, right? So this is what we get when we plug in 20 per T here, which is 90%, right, of 50,000, right? Because it was 0.9 to 50,000, right? All these other answers, right? If we look at 28, well, it's 20 times the time. So essentially what that would be is raising this 0.9 to the power of 40, which would not be giving a 0.9% in 20 years, right? It would be giving 0.9 times itself 5 times, which is not 0.9, right, in 20 years. If we look at B, well, B in 20 years is giving 10%, right? Because if we put 20 in for T, we'll get 50,000 times 0.1. That's going to give us 10% of 50,000. We're not looking for that. And A, of course, again, it's distorting it. It's going to give us something to the power of 400, which is not 0.1% or 0.9%. So that's why D is correct, because in 20 years, well, D gives us 90% of 50,000. That's all. It's the only reason, right? And again, in another 20 years, it's shrinking and so on. Question 29. So we're given a table, and we're given some information about that table. So it says the incomplete table above summarizes the number of left-handed and right-handed students by gender at the Kaysville Middle School for 8th graders. There's 5 times as many right-handed female students as there are left-handed female students, and there are 9 times as many right-handed male students as there are left-handed male students. So there's a total of 18 left-handed and 122 right-handed students in the school, and which is the following is closest to the probability that if we were to select a right-handed student, they would be a female. And we're assuming that none of them are both left-handed. Well, we can think about it this way, right? We know that there's essentially 5 times as many right-handed females as left-handed. So they're in a ratio of 5 to 1. We know that there's 9 times as many right-handed males as left-handed males. So, based on that information, if we say that if we use F to represent the left-handed females and M to represent the left-handed males, we can say that, well, F plus M is equal to 18. The total of those two quantities will be 18. And now we know that, well, there's 5 times as many right-handed females as males. So we can say, well, okay, 5F plus 9M, because there's 9 times as many males as right-handed males as left-handed males, is equal to 122. So we can create the systems of equations and solve it to find out, well, okay, what are the values of left-handed and left-handed females and left-handed males? So F left female, and then M is a left male. And using that information, we can find out, okay, how many right-handed males are there. And once we do that, or how many right-handed females are there, and then once we do that, we can calculate the percentage here. So let's solve the system. So I'm going to use a substitution. We'll get F is equal to 18 minus M. So we'll get 5 times 18 minus M plus 9M equals 122. 18 times 5, that's 90. It's minus 5M plus 9M equals 122. It's going to be 4. Minus 90. Well, what's that minus 90? We can do a simple carrying here. 11. 2 minus 0 is 2, sorry. 12 minus 9 is 3. Let's see, 4M is equal to 32. So M is equal to 8. So our left-handed males is 8. And if our left-handed males is 8, well then our left-handed females is 10, because that equation at the top here has to be satisfied. Okay. So now we want to find, okay, what's the probability that a right-handed student selected at random is female? Well, if there's 10 left-handed females, then we know that there has to be 50 right-handed females, because the left-handed females is 5 times as small as the right-handed. So there's 50 right-handed females. And we're drawing this out of a population of 122 right-handed students in total. So what is the probability that a right-handed student selected at random is a female? That's going to be 50 over 122, right? Because there's 50, of course, 50 right-handed females over the total population of both right-handed males and females. And so if we were to divide this out, we'll get this is approximately equal to 0.41 or 41%, and that is closest to 8 in this case. Great. So again, just a matter of making a system here. You fill in the values here. It's not a necessity. You can use this chart to your advantage if you'd like. I'm not going to, but yeah, again, it's totally up to you. All right. In this equation above, B and C are constants. We know that B is C minus 1/2. Okay, if we know that B is C minus 1/2, then what relationship can we get between X and Y? Well, we know that B is C minus 1/2, then we can plug in C. We can use this value and substitute it into the first equation. So we can get C in terms of B. So we'll get 3x plus C minus 1/2 equals 5x minus 7. And again, down here, we're at 3y plus C is 5y minus 7. So if we were to subtract the bottom equation here from the top one, right, if we subtract the whole equation, we're going to get the C's canceling. And if we do that, right, we'll just get a relationship between X and Y, which is what we need to solve the problem. So if we do this, we'll get 3x minus 3y plus 1/2 equals 5x minus 5y minus 7 plus 7. Those are going to cancel. And the C's cancel as well. So now we have a relationship between X and Y. So now they want us to find, okay, which of the following is true between X and Y? So let's get the X's and Y's both on one side. So we'll do minus 5x. So we'll get negative 2x here. We'll do plus 5y, plus 5y. We get plus 2y. And we'll bring the negative 1/2 over to this side. Equals negative 1/2. So if we divide the whole thing, we want to get X minus Y. If we divide the whole thing by negative 2, right, we'll get X minus Y. Divided by negative 2, we'll get X minus Y is equal to negative 1/2 divided by 2 is 1/4, right? So again, all we're doing here is dividing by negative 2 to get back to that original expression. We use subtraction, that's a system of equation solving method, but in this case, we use it to cancel out C, and then we found that X minus Y is indeed 1/4. These are all wrong because they don't obviously put out the same equation. Question 35. So an online store is receiving customer satisfaction ratings between 0 and 100. And in the first 10 ratings, the store receives an average of 75. So we want to know the least value the store can receive for the 11th rating and still be able to have an average for at least 85 for the first 20 ratings. So the 11th rating can be lower. We're wondering, what's the least value it can relieve and still be able to bounce back, right? That's what we're looking for here. So we're taking an average of 20, right, essentially here. We know the average for the first 75, first 10 was 75. So 75 essentially plus we have our 11th value, we'll call that X, right? Plus another, we'll call it 9Y, right? Essentially what we're doing here is we have 75, right? And we have our 11th rating, right? And then we have 9 other ratings, right? I'm wondering what happens if we, so we have our 11th rating with 9 other ratings. we're essentially saying x can be low, but what is the smallest value x can be for this x plus 9y to still have a value, right, that produces an overall average of 85. So this would have to be equal to 85, right? And so in solving this equation, right, we get 75 plus x plus 9y equals 85 times 2, that's 170. Subtracting 75 minus 75. We get x plus 9y equals 95, right? And if x plus 9y equals 95, well, that essentially means the average of x and 9y, well, is equal to 95. So we want to know, okay, what's the smallest value x can be in order for this to happen, right? Divided by 10 is 95, essentially. So if we look at only this part, we're saying, okay, the average of this last part here is equal to 95, because 75 plus 95 over 20 is 85. So what's the smallest we can make x for this to work? Well, let's make y the maximum. So if we let y be 100, right? Then I'll put it up here at the top here. We have x plus 900 over 10 equals 95. Well, essentially we have to solve this now. If we multiply both sides by 10, we get x plus 900 equals 950. And therefore, x is equal to 50. And that's our answer. And the reason that's our answer is because we essentially said, okay, we're going to make x the smallest. We're going to let y be the largest it can be, and we're going to let x be the smallest it could be. And that's going to allow us to find, okay, what's the smallest the 11th value could be, right? And we could still be able to bounce back by maximizing it, right? So in this case, we're essentially solving for this expression. We say, okay, this is equal to 95, right? Therefore, the average of this, well, if we divided this whole thing by 10, would be 95, right? Then we plug in 100 for y, and then we solve for x. Right, so that's how we got our answer. All right, let's take a look at 36. So we have systems of equations, inequalities, if you will, and we're going to try to solve these. So in an xy plane, a point with coordinates a comma b lies in the solution set of the inequalities above. So we want to find, okay, what's the maximum value of b in solving this? So we want to say, okay, what is the largest value of b that allows this solution to be solved? So what's the largest y output? So we can do this by solving the equation. Since we know that y is less than or equal to 5x, right? Then we know that since y is less than or equal to 5x, right? And y is less than or equal to this, right? Then we can set these two quantities equal to one another. So negative 15x plus 3,000 equals 5x. That means 20x equals 3,000, right? And then 3,000 divided by 20 is 300 divided by 2 is 150. That's not our maximum value. So essentially what it's saying is, well, if x is equal to 150, then this equation is sort of minimally true because, well, if x is 150, right, then let's see what happens. If x is 150, actually, no, this is the best way to think about it. By setting them equal to each other, right, we're taking the largest possible value that x can assume, right? We're not saying it's anything less than that. We're saying, okay, assuming both of these equations are equal, right, what's the largest possible value that x can assume, right? And essentially, by setting them equal to one another, we're taking advantage of the fact that this is less than or equal to, right? If we said they were if we assumed any smaller values, we wouldn't be getting the maximum. So by setting them equal to each other, we're assuming we're getting the maximum x value, right? So the maximum x value, therefore, is 150, right? And therefore, if we want to find the maximum value of, in this case, the maximum value y here, well, we can look at one of the equations and we can plug it back in to find the maximum value y. So y is less than or equal to 5x, right? We're essentially taking the equal case because obviously if y is anything less than 5x, y is not going to be maximized because y is not going to be the smallest. And therefore, if y is equal to 5 times 150, then y is equal to 750. So again, all we did here is we treated this like a system of equations and not a system of inequalities, right? We took the largest possible case out of both of them, and then we found our y coordinate. So that's essentially what goes into solving problem. Problem 37. So problem 37 gives us a law called Little's law, which relates n and r and t, where r is the rate of shoppers per minute, t is the average time they stay in the store, and n is the average number of shoppers, right? I'll give us an example of how this is applied, but let's take a look at 37. So 37 says, the store owner determines that during business hours, approximately 84 shoppers per hour make a purchase, right? And they spend an average of 5 minutes, that's going to be our t, in the checkout line. So now we want to find, okay, what is n, right? Well, let's remember from the beginning that r here is relating shoppers per minute, right? Not shoppers per hour. So we have 84 shoppers in the store for every 1 hour. which is the same as 84 shoppers, put S there, and every 60 minutes. So if we take 84 and we divide that by 60, well, what do we get? Well, we get, we do some cancellation here, we get 12 times 7 over 12 times 5, which is 7 fifths. So therefore, every minute there is R is our 7 fives. Our shoppers per minute, therefore, is 7 over 5. That's our R. So looking at our equation, we get N equals 7 over 5 times T. And we know our T is 5 because we're referring to the checkout line here. So on average, how many shoppers are on average are waiting in the checkout line to make a purchase? Well, we simply plug in our T to this equation, which gives us N equals 7 over 5 times 5, which equals 7. So our final answer here is 7. Question 38. The owner of the Good Deal store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour. So 90 over 60 minute. Just gonna write that there. And each of them stays an average. T equals 12. The average number of shoppers in the new store at any time is what percent less than the average number of shoppers in the original store at any time? So we found our 7, right? And now we're going to find our percent. So let's do the same calculation to find our N. So N is equal to RT. We know RT is 12, and know our rate is 9 over 6. 9 over 6 is the same, because we're canceling out the zeros here, as 3 over 2. So N equals 3 over 2 times 12, which is 18. And we're relating, we want to know the average number of new store in the shop, the average number of new shoppers, the average number of shoppers in the new store at any time is what percent less than the average of numbers in the original store at any same time. Okay. Let's see what the original store is. 45 shoppers. And we calculated, well, there's 18 shoppers based on Little's law here. So is what percent less than the average number of shoppers in the original store at any time. So we want to find, okay, what percent is this? Well, we're looking at essentially 18 over 45. What is 18 divided by 45 as a percent, right? Because that's what percent less there is. Well, they're the opposite. So 18 over 45, right, is 9 times 2 over 9 times 5, which is 0.2, right? Or rather 0.4. Which basically says, okay, 18 is 40% of 45, right? And so the percent less, what percent less than the average number of shoppers in the original store at any time? What is that percent? Well, that percent is going to be 60, right? Because essentially 45, 18 over 45, right? That's 40% of 45. That 18 is missing the 60% of shoppers that the 45 had, right? So therefore our answer is 60. We're missing those other 60% of shoppers. So that's the difference. We're asking for the percent less. It's 60% less than the original.